And into section 8.4, multiplying special cases. So we've dealt with multiplying binomials. Now we're going to talk about some special cases of binomials and how to multiply those. The objective of this section, to find the square of a binomial and to find the product of a sum and difference. So of course sum means answer in addition, difference, answer in subtraction. An essential thing to understand, there are special rules you can use to simplify the square of a binomial. So much like in many other fields of math, there are simple shortcuts, or tricks you might call them, that you can use to make problems like this more simple. So here's a real construction problem to consider. It's going to be very much linked with the concepts of this section. You're making square invitations for a party. You start with a square piece of paper with 6-inch sides. You reduce both its length and its width by x, as shown. What is the area of the invitation? Justify your reasoning. The new height would be 6 minus x inches. Likewise, the new width. It used to be 6 inches. We've removed x inches, so it would also be 6 minus x inches. And so what we need to do to find the new area is to simply multiply these two binomials, 6 minus x times 6 minus x. And using our trusty new acronym FOIL, we will first multiply our first terms, 6 times 6, 36. Then our outer terms, 6 times negative x, so minus 6x. Then our inner terms, negative x times 6 minus, and we write that also as 6x. And our last terms, negative x times negative x, would be plus x squared. Now combining like terms, we'd notice, well, minus 6x minus 6 more x's, that results in a negative 12x. So we have 36 minus 12x plus x squared. And then reorganizing so that we have standard form with the larger or the higher values of x, the higher exponents to the left. X squared minus 12x plus 36. Note, even though there's no plus sign over here, it's a positive value, so when we rewrite it, it must stay a positive value. X squared minus 12x plus 36 inches squared. A key concept to take note of, the square of a binomial. So often we will simply be squaring a binomial, and it says here the square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. So that may be kind of hard to grasp just reading the words, but when we take a look at what's truly going on here, the algebra of the problem says a plus b squared, so our binomial is a plus b, and we're squaring it. That will equal a squared. Note that's the first term squared, so a squared, plus 2 times a times b. And notice that a times b is simply the product of our two terms, and we're multiplying that by 2. And finally, b squared, our last term squared, our second term squared. An example of this, x plus 4 squared equals x squared, again first term squared, plus 8x, again 2 times x times 4, 2 times 4 is 8, 8x, plus 16, the second term squared. Look at a difference, a subtraction binomial, a minus b squared equals a squared minus 2 times a times b plus b squared. Note the plus b squared because we have a second term of negative b times negative b, positive b squared, or plus b squared. An example of this, x minus 3 squared equals x squared minus 6x plus 9. Why it works. So we can take a look at these area models. First, an example of a plus b squared. Note the length and the width, or the side length of this original square is a plus b, A represented in blue there, the width of A, and then B represented in green. We multiply these things to form rectangles, and when adding them together, note A squared, that large blue square, is simply our first term squared. AB plus AB, the two green rectangles, well, there are two of them, so that explains the 2 times the product of our two terms. AB is the product of our two terms, and there are 2 green rectangles there. And finally, B squared represents our second term squared. Adding them all together, we have A squared plus 2AB plus B squared. A very similar model for difference. Note that the negative B is represented as red, so that may help explain why A minus B can actually appear to be A plus B. That value B is a negative, and so those rectangles are represented in red. Again, we have A squared, A times A, the blue square. We have 2 rectangles representing A times B, so when adding those together we would have 2AB. Keeping in mind they're negative, would be minus 2AB. And finally, B squared, our last term, we have one of those. So combining, A squared minus 2AB plus B squared. Now here's our first example problem. Pay close attention, there will be a couple of got it problems following. What is the simpler form of each product? X plus 8 squared. So note we can use that rule from before, which might save us some time as opposed to using the full FOIL method. X plus 8 squared will equal x squared. Note that's the first term squared. Plus 2x times 8, or plus 2 times x times 8, there we go. Because we have our two terms multiplied, that is x and 8, and those are being multiplied by 2. Remember, it's twice the product of our two terms. I was a bit thrown off by the 8 on the right-hand side in parentheses, but that makes sense. They didn't want to change the order in which we're multiplying and still needed to represent multiplication. So 2 times the product of our two terms x and 8 makes good sense. Plus 8 squared, our second term squared. Simplifying, we find that to be x squared plus 16x plus 64. Example B, or part B, a difference, 2m minus 3 squared equals 2m squared, our first term squared, minus 2 times our two terms multiplied, so that would be 2m times 3 plus 3. And it looks as though they have left out an exponent. That should be plus 3 squared, because remember we always square our second term. So I will correct that for us, and I'm sure our textbook manufacturer will be sending me a check in the mail. Alright, continuing on, we find, simplify, we find 4m squared. Remember this property of exponents, the 2 will distribute to both the 2 and the m, so 2 squared is 4, m squared is m squared, minus 12m, 2 times 3 times 2 is 12, 12m, plus 3 squared is 9. And here's your first of 2 opportunities to show that you have got it based on this example. What is a simpler form of n minus 7 squared? Make your selection from the choices below. And your second opportunity to show that you have got it. What is a simpler form of 2x plus 9 squared? Please make your choice from the options below. Example problem number 2, applying squares of binomials. So here we'll see an application of what we've learned. Exterior design. A square outdoor patio is surrounded by a brick walkway as shown. What is the area of the walkway? Well, step 1 tells us, find the total area of the patio and the walkway. Well, so we have the patio, and we have a walkway of 3 feet. So notice the width of the walkway is 3 feet. The patio is x feet by x feet square. So therefore, our total side length will be x plus 6 feet, a binomial. And since we need to find area, we'll simply square that binomial. Right? To find the area of a square, we simply multiply side times side, which results in side squared. So, to do this work, x plus 6 squared, we know from our previous examples, that will equal x squared plus 2 times x times 6 plus 6 squared. Simplifying, we find that equals x squared plus 12x plus 36. Step 2, find the area of the patio. Well, the area of the patio is x times x, or x squared. Step 3, find the area of the walkway. The area of the walkway will equal the total area minus the area of the patio. Right? If we consider that the total area minus the area of the patio, if we were to take that square and remove it, what would be left is the walkway around. So to find the total area, we'll take the total area, to find the total area of the walkway, we'll take the total area minus the area of the patio. So we take our trinomial that we arrived at in step 1 and simply subtract x squared. Subtracting the x squared from its like term x squared, the x squared goes away completely because x squared minus x squared is 0. Plus 12x plus 36, we then simplify to find the area of the walkway is 12x plus 36 square feet. And here's your chance to show that you have got it based on that example problem. In problem 2, suppose the brick walkway is 4 feet wide. What is its area? So using this diagram and similar calculations, find the area of the brick walkway in this example.